Hi, boys and girls. Welcome back to Hands-on Science at Home. I'm Mrs. Levin from Team Purchase.
I'm Mrs. Viola from Team Geneseo.
Hi, boys and girls. It's Miss Messina from Team Cortland.
Hi, it's Mrs. Cabrera from Team Stony Brook.
Hi, it's Miss Hidalgo from Team Geneseo.
Everyone, it's Mrs. Schwartz from Team Cortland.
So today, our big question of the day is the speed of water molecules different when the weather is hot or when it's cold? Miss Viola?
We could try to heat water so it boils. I always see the water moving when it's boiling.
So, boys and girls, remember the other day when we put the food coloring in the water and we showed that the particles were moving? Could we do something like that? What if we look at both hot and cold water and, like the other day, add food coloring to the water?
What should we keep the same? Let's think about that and make notes for a second. Should we use the same amount of hot and cold water in our experiment?
Yes. What else might change our results? Should we use the same type of cup for the hot and the cold water?
Yes. Should we use the same number of drops for each color?
Yes. Do you think it's important that we put the food coloring in at the same time?
Yes, keeping these variables, amount of water, type of cup, number of drops of food coloring, the same will help us see if temperature affects the motion of water molecules. Remember, we can only change one variable.
Remember, for this demonstration, you're going to need a couple of things. You'll need 2 clear plastic cups, one with cold water and one with hot water, and food coloring in 2 different colors. Remember, you can use something else like soy sauce or a dark juice. Stop the video and restart when you have your materials. If you don't have any of these materials, it's okay, because you can just watch our demonstration.
Okay, so Miss Levin is now going to place 1 drop of each color into the hot water and cold water at the same time. So let's take a look.
Let's take a look. So now I have my cold water. There's the cold water, and here's the hot water. And I'm going to label them cold and hot so you can tell which one is which. So here's the hot. Hold on. That look good? So you can tell which one is the hot and which one is the cold. Remember, our question is, are the molecules going to move more in the cold water or the hot water? So I want to be really careful not to move my molecules. I have a little piece of ice in here, so let me get that out and then let the water sit for 1 second. So I'm going to just wait till the water is nice and still. I don't want to pick it up and make the molecules move. So I'm going to put 1 drop in each at the same time. And then I'm going to put 1 drop in each at the same time, right? Okay, it was almost the same time. Now we're going to watch and see what the mixing looks like. We need a light on.
So make sure that you guys are observing carefully over these next few minutes what's happening in these 2 different cups of water.
So remember, this is the hot water, and that's the cold water.
Did you notice the difference in how fast the colors mix together? What could that tell us about the speed of the molecules in the hot and cold water?
So keep watching and observing. What do you notice about the molecules in the hot water? What do you notice about the molecules in the cold water? You might have to watch it a little bit longer. I think it's pretty clear. So you're going to answer the questions on the PDF, on the activity sheet, and you're going to submit that. You can do a screenshot of your work, and if you've forgotten how to use the PDF, you can go back and look at the video that we posted last week about how to edit a PDF. Then we'll see you tomorrow for part 2 of the big question: is the speed of water molecules different in hot water and in cold water?
Good luck, boys and girls.
Enjoy.